Let's talk about some pitfalls of loops. First off, you've already seen the pitfall of an infinite loop. And we talked a little bit about how to use a control variable to control that infinite loop. A loop control variable is tested in the while statement. If the test expression is true, the body of the while loop takes action. So we have to make sure we alter the value of the loop control variable so that the while statement eventually evaluates to false. That's how we ensure that an infinite loop doesn't happen. Sometimes we can make a mistake by improperly bracketing. If you remember from previous discussions, if you don't put brackets around some statements, the system will look at the first statement and it won't read the next statement. So on this slide you can see that this particular loop control variable is never iterated, it's never incremented, and so hello continues to print indefinitely. This is a problem with improper brackets. Remember, in Java, indentation has no effect. It's important that we define that a loop control variable has to be altered and stored with a new variable. So in this case, although you can't really see it, I think, on the slide, but this is loop count equals loop count plus 1. The equal sign assigns a value to the variable on the left. The variable should be altered within the body of the loop. Otherwise, you have a loop that's indefinite. Another mistake you can make is creating an empty body using a misplaced semicolon. And you can see that problem here. Because we put a semicolon at the end of the while, the loop body is never reached. We basically create an empty loop. And loop count, because the body is never reached, continues to evaluate to true because 1 is never incremented. When that happens, we have an indefinite loop. And of course, that can be fixed by adjusting the right semicolons. That of course brings us to this idea of loop control variables. How do we change the variable? Well, one common way is incrementing the variable, and you've seen that already, where we increment it by 1 each time until a threshold is reached. Usually, we do that by adding 1. We can also decrement the variable and bring it down to a certain lower limit. In the case here, you can see our loop count variable, our loop control variable, is 3. Starts out at 3. And we decrement each time until the loop control variable reaches 1. So this also displays hello twice. Well, how do you know which method to use? Well, you can start the value at 0 or 1. Depends on how you want to work it. You increment by 1 throughout the loop, and you stop when the loop control variable reaches the limit. That's if you're going up. Sometimes you're going down because what you've received is a higher value, something like a factorial, and you might want to decrease the value. Basically, you choose the best method depending on what you're working with. Now, while loops are controlled by events, something that happens from the user. They can be event-driven. They can also be loop control-driven. But in an event-driven loop, we're bringing in values from the user and we're driving our decisions. Because we can do that, we can validate data with the while loop. We continue to run the same statements until a user puts in the right data. When we use a while loop for that purpose, we're going to prime the data. That is, we're going to ask the question first, we're going to check whether or not the response was correct, and then we're going to run the statements within that while loop. I'm going to pop open some code here that can show that really well. So let's look at this code where we prime the value. Alright, so here's this function, and you can see it here. We have a function that has an interest rate of 0.3%, and of course you can modify that interest rate. And you can also show a different balance. And I'm just going to point out that I could do, well, we're not going to mess with that right now. But let's go ahead and run the code, and we'll talk about what actually happens. Right? So bank balance, I'm going to enter a balance of $10,000. and I can hit 1, and it's going to show you the balance is $10,300 because that's based on a 5% interest rate, right? And every time you run this, it's going to increase the bank balance, right? So what happens is, I understand what happened. Interest rate 0.5. You know what I forgot to do is I actually forgot to recompile my class. I'm still running a 3% balance. So this is actually running 3% balance, and you can see what's happening right there. But we've primed the input, and we have 1 for yes. And once you enter 1, it's going to run the balance each year. So you hit 1, it keeps running the next balance, right? And so it's primed here, and then it runs it again here, and it continues running it until a response is no longer 1. So the interest calculation is fairly straightforward. We're just multiplying on the balance. We're multiplying the current balance by, let me see where the interest calculation actually is. Here it is, here it is. Here's the balance. Okay. Year at interest rate. Here it is, balance plus balance times interest rate. Yeah, and so this gives you that amount here. Okay, and you could also multiply, you should get the same value if you multiply balance times interest rate plus 1, like that. It will give you the same basic value. I'm going to compile this time so you can see that difference. I'm going to go ahead and compile bank rate. Oh, let me get out of here. Alright, I'm going to compile bank rate, bank balance. Oh man, I did the wrong thing. Yeah, let's get out of there. Alright, so let's see. Let's just java c.bankbalance.java, and then you should be able to see those changes I made. Alright, so now I can java bank balance, and I can enter bank balance 10,000, and then 1 for yes, 5% interest, $10,500, and then each time it does that, you're going to see that 5% interest rate as it keeps jumping up. Alright, so we're going to stop here. Just wanted you guys to see how this prime works to continue to run a loop until a user exits. Thank you.